sulfate and binary, or
Say that again.
what do you mean, like the IDE, like that's binary?
IDE?
Yeah.
Yes. There are a couple polyatomic ions that end in IDE, like hydroxide also ends in IDE, but these are the ones. Remember I said no, technically you don't have to memorize them, but you should know them because it's going to make your life a lot easier if you know them. Okay? So if it ends in IDE, yes, it's going to be a binary. So I'm going to do a binary compound right now, and we're going to add something to what we already know. Let's take iron and oxygen, and let's name it. Okay? When we name this, it's binary, so we know it's going to end in IDE. The first part stays its own name. That's going to be iron. What's the ending going to be? Oxide. Okay, easy peasy lemon squeezy. Now let's take this guy, Fe2O3. What's the name of that guy? Iron oxide. Okay. So I say to you, go to the chemical supply closet and get me some iron oxide. Which one are you bringing me? Are you bringing me FeO or are you bringing me Fe2O3? How do you know? They're both iron oxide. Okay. Well, let's back up a step. Are they the same stuff? Is FeO and Fe2O3 the same? No, they're not the same. They're totally different compounds. One's made of 1 iron and 1 oxygen. One's made of 2 irons and 3 oxygens. So they're not the same thing. So I can't say to you, go bring me some iron oxide, because I don't know which one you're going to bring me. Okay? Now, let's take this iron oxide. I'm going to get a new piece of paper and we're just going to analyze that 1 iron oxide, FeO. Okay? I want to know what the charges are on the Fe and on the O. Can we figure out what the charges are going to be? The oxidation numbers, which are the charges. Okay? Let's look at Fe on your periodic table. Do you see how it has a +2 and a +3? Okay? Which one did I use to make this compound? Let's look at oxygen. What's its charge going to be? -2. If that one is a -2, and I know that the whole thing has to add to 0, which one was used here for the iron? The +2. Okay? That +2 right there, that 2 came down, this 2 from the oxygen came down on the iron, and these reduced to 1 and 1, which is why I ended up with FeO. Because this iron that was used to make this iron oxide was a 2, when we write the name of this compound, we are going to write iron with a Roman numeral 2 oxide. I don't know why my X is right on top of my O. This right here indicates the charge on the cation. Now, everything I've given you up until this point, I was very, very careful about what I gave you to name, even on that quizzes that we just did. I only gave you things from group 1, group 2, and aluminum. Because if you look at group 1, do you see how it only has one choice, +1? And group 2 only has +2s. And group 13, usually like boron and aluminum, only has +3s. Okay. I didn't give you anything in the transition metals because I didn't teach you this yet, but now I did. So if you have a metal, a cation, that is going to have multiple oxidation numbers, when you go to name it, you have to write the oxidation state in Roman numerals of that cation. Okay, so let's look at Fe2O3, just because we have it up here, Fe2O3. When you have Fe2O3, what I would do is I would start with the oxygen. And I'd say, I know oxygen has to be -2. That's my only choice. When I look at the periodic table, oxygen is 99.9% a -2. That's why they gave it to you on your periodic table. It's not always a -2, but most of the time it's a -2, especially for Regents chemistry. What number went here? +3. +3. So when I write the name of this, I am going to write iron, and then I'm going to put a Roman numeral because that iron has multiple oxidation numbers, multiple charges. I'm going to put a 3 because I used the +3 charge, oxide. Did I lose you, or are you okay out there? Okay. Let's try another one. CuO. What is the name of that? Go ahead. Go ahead. No. If there's only one, you don't write the Roman numeral. If there's multiple, you write the Roman numeral. Yes. Okay, so good question. Let's just go back. Let me pull up a periodic table for a second. And let's look at the actual periodic table. If I was writing a name of a compound for, let's say, lithium and oxygen, I wouldn't write lithium 1 oxide because lithium only has 1 oxidation number. That's not what Ryan's question was. Okay. If, however, I am using chromium and oxygen, because chromium has multiple oxidation states, I'd have to tell the person which oxidation number was being used in that particular formula. Was it chromium 2, chromium 3, or chromium 6? So it would either be chromium Roman numeral 2 oxide, chromium 3 oxide, or chromium 6 oxide. Now, what Ryan was asking is, and I don't even know if any of these have a +1. Oh yeah, silver, but it's only got one number there. So it would be silver 1 oxide. You wouldn't write the 1 in that case because there's only one choice. Mercury has a 1. Okay, so it would be either mercury 1 or mercury 2 oxide. Okay, anytime there are multiple oxidation numbers, you have to write the Roman numeral. Tomorrow when we come in, we are going to be practicing those. Is the period over already? Yeah. Oh my goodness. You're going to leave me already?